In this video, we're going to look at how to find the area versus the volume of a rectangular prism. So the first thing I'm going to do is draw a little sketch of this prism. So I'm going to say that one of the lateral faces, or one of the shapes that make up this object, is a rectangle that is twice as high as it is wide. And I'm going to say that the ends go like this. So I'm doing these three little lines that are parallel, going off on an angle, give the impression of this being drawn sort of in 3D. It's called perspective drawing. So the dimensions are 2.5, 2.5 this way, and it's going to be 5 tall. So if I were being asked to find the volume of this object, that's 3 dimensions. It's the space contained within it. So I would be taking in 3D length times width times height to give me the volume. So I've got 2.5, 2.5, and 5. And that's 31.25. And in this case, they are measured in inches, and they're cubic because it's a volume. Now, to find the area, I could manipulate this object in my mind and think about the rectangles that make up each of the sides and the 2 little squares on the top and the bottom. But instead of that, I'm going to show you a net. So here's the net for a particular rectangular prism. So the 2 little squares on each side here, the blue ones, are the top and the bottom of this box. And then each of these, one purple and one yellow, like this, is this rectangle 2.5 by 5. So if I start folding this up here, you can see I've got my rectangular prism there. There we go. So to find the area, once I've unfolded it, I can see what I've got going on here. And I can kind of simplify the process a little bit, because I could look at it as each of these little squares is 2.5 by 2.5 and multiply it by how many of those I have. Or I can do a little bit of a shortcut. Given that the dimension of one of the squares is 2.5, I know that 2 of the squares is 5, and I know that all the way across here, 4 squares wide, is 2.5 times 4, which is 10. So in my net, I'm going to draw this on my paper here. So this is 10. This is 2 squares high. That's 5. and these little ones are 2.5. So finding the area, it's sufficient, it's enough for me to find just the area of the larger rectangle that makes up all of the side surfaces, and then find the 2 ends. So 5 by 100, or 5 by 10, excuse me, is 50. So that 50 describes all of the yellow and all of the purple that I've got down here. And then 2.5 by 2.5 is 6.25. So the area of each of the little squares on each side is 6.25. So in the end, the total surface area is going to be 6.25, and there's 2 of those, one on the top and one on the bottom, plus that 50. So that works out to 62.5. And again, this is inches, but it's 2 dimensions this time, so it's now inches squared, or square inches. So by way of a little verification, I am going to consider it as how many of the smaller squares do I have, and then just multiply that as well. So if I just took one of the little squares, that's 2.5 by 2.5 inches. So verify 2.5 by 2.5. And then how many of those little squares did I need to make this entire net? Well, I needed 8 here, 4 and 4 is 8, 9, 10. So I need this number times 10. And if I verify that, 2.5 times 2.5 times 10, look at that, it's the same number, 62.5. So when we ask you to verify your work in mathematics, what that means is it doesn't mean do it again the same way, because you may just be repeating the same mistake. Verification involves finding another method that will generate an answer, and then you can compare to see are they the same answer. If you get the same answer using 2 different strategies, then you can be fairly certain that it's the right answer.